Okay, everybody, we're going to take a look at doing a vector difference now with components. Instead of doing it graphically head to tail, we're going to use the method of components. And I picked two vectors that are a little more involved as far as drawing goes, and I've already set it up a little bit beforehand to speed up the process. Vector A, as you can see, is 72.4 meters at an angle of 32 degrees east of north. It's a quadrant 1 vector that you can see that I've drawn right here, and the angle is again 32 degrees east of north. You point northward and then you turn 32 degrees towards the east. Vector B is 57.3 meters at an angle of 36 degrees south of west, which means that we point westward and then we turn 36 degrees towards the south, which puts us in quadrant 3. So here's the setup of the two vectors. Now, as we do it before, we want to resolve both vectors into their x and y components, and we want to actually draw what they look like. And what we will have here, starting with vector A, I'm going to start with the x component. It's going to come out like this. Okay, that's going to be the x part of A, and coming up to that will be this arrow, which will be AY, the y part of A, and I've resolved it into its two parts. Okay, and let's make that look a little bit neater. There's the y part of A. Now to do the math, we will have that AX will equal A sine theta, so that'll be 72.4 meters times the sine of 32 degrees, and on a calculator you could confirm that this comes out to 38.37 meters. The y part of A, AY, will equal 72.4 meters, and it's the adjacent side of the triangle, the right triangle, so it'll be the cosine of 32 degrees. On a graphing calculator, scientific calculator, we would get that AY equals 61.40 meters. Let's also then draw the x and y parts of vector B. I'm going to start with the y part to set this up. There's the y part, BY, and the x component, BX, will look like so. And let's figure out what their values are. And BX will equal 57.3 meters. Let's clean that up a little bit. It will be 57.3 meters, and the x part will be times the cosine of 36. The cosine of 36, and if you look carefully at the drawing, you can see that BX is heading in the negative direction, westward, so there's a minus sign in front of this, and when you work out the cosine and do the calculation, you get that BX is a minus 46.36 meters. BY, the y part, will also be negative. It's pointing in the negative y direction, y-axis direction, or towards the south is negative. It's going to be a minus 57.3 meters, and that's opposite this angle of 36 degrees, so that's going to be the sine of 36 degrees, and that will work out to be a minus 33.68 meters. So we have all the parts figured out, AX, AY, BX, BY, and we've replaced the original vectors with their perpendicular components. Now, if we want to find in part A, we want to find the magnitude and direction of vector B minus vector A. So let's recall that what that means. There's a couple of things we want to look at. First of all, let's write that down here, vector B minus vector A. Now when we do it this time, what's going to happen here is that we're going to find dx, the x part of the difference, and we're also then going to find dy. So what's dx going to be? What's going to be the x part, bx, simply minus the y part, I'm sorry, the x part bx minus, it's going to be bx minus ax. You're going to subtract the x components. Okay? And we're going to look at our numbers and be a little careful about this. So we look at bx. Bx of our list, from our list over here, is minus 46.36 meters. And we're going to subtract ax. Now ax is pointing to the right, but we're going to flip it over because we're subtracting. We're going to move it. It's going to be actually pointing in the other direction now. If we think about it, in terms of how it looks graphically, this will be minus 38.37 meters. And when we subtract these two, add their negatives, how you want to say it, we get a minus. The dx equals minus 84.73 meters. The y part of the difference, dy, will be the y part of b minus the y part of a. So it's by minus ay. So we go to our list. By is actually a minus 33.68 meters minus ay, which is, we're going to subtract 61.40 meters. Okay, we don't change the signs, we just do the subtraction straight up. So when we subtract these two, we get that the y part of the difference is going to be minus 95.08 meters. Now, what we're going to do is what we've always done before, is we're going to draw the way we did with resultants. We drew Rx plus Ry. Now we're going to draw dx plus dy, realizing that they're both negative. So it's going to put us in quadrant 3 if you think about it a little bit. Now to draw this thing, let's move down a little bit and take a little. We've got dx is going to be minus 85 basically, and this is going to be minus 95. We're just going to draw them proportionally to get a sense of how they look. So again, this would be point P, which is like the point in the original drawing. It's the origin. We're going to go over what we're going to call minus 85. We're just going to eyeball it. It's going to be this big, nothing fancy. And this is going to be minus 84.73 meters. Then we're going to draw, do the head to tail thing here with the differences, just like we do with Rx plus Ry. We're adding components, and that's going to go, it's going to be a little bit bigger. Put the tail of the second at the head of the first graphically. Bring it down here. Make it about 4 blocks long. Actually, it should be a little bit longer. So let's just make it a little bit longer. Nothing dramatic here. We just get a visual on this. So it's going to be minus 95.08 meters. And we're going to draw the resultant from the tail of the first towards the head of the last. It's actually a difference, but we're using the same technique. And this will be the magnitude of D. And then we'll have this angle near point P, which is going to be theta D, like so. Well, the magnitude of D, as everybody knows, will be the Pythagorean theorem, which will simply be the square root of the sum of the squares of the legs of the triangle. So this will be minus 84.73 meters squared plus minus 95.08 meters squared. The square root of the sum of the squares. Not a hard thing for you to do. You'll get that the magnitude is 127.4 meters if we want to round it to 4 sig figs. And if we go for theta D, we'll use the inverse tangent. Tangent to the minus 1, opposite over adjacent will be, opposite side is minus 95.08 meters over the adjacent side, which is minus 84.73 meters. Work it out. Make sure we're in the degree mode. We'll get the angle is 49 degrees. And you got to think about compass directions here. So we need blank of blank, which is kind of important for us. And what we'll have here, if we look at our drawing, the first arrow points towards the west, and to get down to D, the difference, we turn towards the south. So it's going to be 49 degrees south of west. Okay, so there is our answer. It's 127.4 meters, 49 degrees south of west. Now, I'm interested, and we're interested in finding the other problem, the other answer for part B. That's why I'm drawing this line. And we're going to go back up here. Scoot us back up. We want to do the vector difference of vector A minus vector B. Now, if you learn anything from the previous example, you might already know the answer, but let's just work it out in detail to make sure we're convinced that it's right. So in this case, dx will be ax minus bx. So you take the x component of A and you subtract the x component of B. And you do it straight up just with the numbers you have. So ax, everybody, this is going to be, going to need to save on space here. This is going to be 38.37 meters minus 61. I'm sorry, that's the wrong number. Minus, notice there's a negative for B, so it's going to be minus a negative 46.36 meters. So we're going to be adding here, and we're going to get that this equals a positive 84.73 meters. Let's find dy, which will be ay minus by, the y component of A minus the y component of B. And ay, everybody, is 61.40 meters. And we're going to subtract from that by, but that's a minus, so it's going to be minus a minus 33.68 meters. So again, we're adding because we are subtracting a negative, and we will get a positive 95.08 meters. And if you look and do a comparison, we can see that for B minus A, dx was a minus 84.73, and for A minus B, dx was a positive 84.73. And also the comparisons are the same. For B minus A, the dy is minus 95.08, and for A minus B, the dy is positive 95.08. Let's draw it quickly. Dx plus dy. Again, details matter. We're going to go over and up, so it's going to be in quadrant 1. So I'm going to come down here, give ourselves a little breathing room. Okay, I'm going to scoot this up so you can see it, so we don't lose it on the screen. There's point P. We're going to go over like so. For this is 84.73 meters. That's the dx. Head to tail, the tail of the y at the head of the x going up. It's a little bit longer. Comes up about like so. Just so we get something that's proportional. This is 95.08 meters. To draw the magnitude, we've got, oh, by the way, this is heading east for a reference axis. We draw from the tail of the first point towards the head of the last. There's D, the vector difference for this case. Here's theta D, the angle down by point P. I'm using the Pythagorean theorem. I think you know what's going to happen here. We're going to get the same thing that we had over here, just because when we square the negatives, we'll get the same result. So this is going to be 127.4 meters, same magnitude. Let's just convince ourselves that the angle's the same as well. So theta D over here would be, I'm going to move this up so we have a little more breathing room. Theta D is going to be the inverse tangent, the arctangent of opposite over adjacent. That would be 95.08 meters over 84.73 meters. 08, that's 95.08. Sorry about that, gang. I think we know where this is headed. We're going to get, again, 49 degrees, but here's where it needs to get different. We've got the same magnitude for the two vector differences, but we have the same angle, but it's all about the direction. We need to get this part. This is where it gets different and where the difference between the two answers matters. So this is going to be, we're heading east and we're pointing towards the north, sort of like what I'm doing with my pen right now, as you can see. So this will be north of east, and as you can see, these two, B minus A and A minus B, have the same magnitude, but they point in the opposite direction. So with the method of components, we're back to the same conclusion that basically vector A minus vector B is, or however you want to say it, you can start either way here. You really can. We could say basically that A minus B, we'll start it over here, down here. A minus B, vector A minus vector B, equals the negative of vector B minus vector A. Okay, so A minus B, which is this, in quadrant 1, equals the negative of the quadrant 4 vector. It's in the same magnitude, opposite direction. And I think you would also see that this is also true, that vector B minus vector A, okay, which was what we got in quadrant 3, rather, not quadrant 4, is equal to the negative of A minus B, vector A minus vector B. So it works out that vector addition is not commutative, it just gives you the opposite answer with the method of components.